Good morning. Good morning.
Good morning.
Good morning.
Good morning.
How's everyone doing?
Good. How are you, Mr. Dunn?
I am well, thank you.
Mr. Dunn?
So the bell work is up right now. Go ahead and answer the bell work in the chat.
I forgot to do bulk work yesterday.
Oh, somebody took a picture. Good morning, good morning. I saw someone posted online that they had a Zoom meeting with their college professor, and their college professor told them to stop eating during class.
Not if you mute yourself.
What?
Not if you mute yourself.
I don't know if you can see the video behind me, but I've got, wow, that's a hat. I've got a demonstration ready to go today. Morning, Shayla, Mariana, Amari, Arden, Alanis, Ben, Ayana, Ayub. I'm going to assume Adrian. Morning, Zainab. All right, go ahead, answer the bell work in the chat.
Oh, and Mr. Dutton.
Yes, Mr. Cow.
I think Victor is in the wrong time. What time is Victor's CS class?
Victor started at 9, and then he has physics at 11:30.
Okay.
And you need to follow this carefully.
Go ahead, answer the bell work in the chat.
What's wrong with this light?
I'm gonna mute everyone except for Mr. Tout.
Why is your phone on?
They're gonna try. All right, waiting for a couple more people to answer the bell work in the chat. If you want to, you can just send a private message, but do you want to hear your opinion? All right, so looks like a lot of people are choosing solar. Does anyone want to say why they think solar is the best? Elena's already explained a little bit. If you want to participate, just unmute yourself. But is it always available? So what are some downsides of solar? Right. Nighttime, some areas. Which areas of Earth have the highest amount of solar per day?
I'd say probably like ones that are in a more open area and more like more trees, I guess.
Yeah, a more open area. On average per day, if you're in the tropics, then you are going to have a consistent amount of solar energy. If you're in the tropics, you're also going to get more direct solar energy all year round. The tropics would be like the southern tip of Florida, I believe, is tropical. And then down through the equator and down through northern South America. To give you an idea of what we're talking about when we say tropical. And those would be the best places for solar, but you can absolutely get solar through even like southern Canada. You can have reliable solar energy. So it doesn't require tremendous amounts of sunlight in order to have reliable solar energy. All right, so what we're gonna do today is that make sure that you're keeping up with the forum. That's something that you can obviously still do. And Adrian, I'm really digging that hat. The sea level rise is the theme for today. We will be talking about, if we have time today, we'll be talking about question set 7.1. And then that's going to be the focus of tomorrow is question set 7.1 and making sure that we understood 7.1. And then on Friday, we'll be doing 7.2, the lecture for that. And that will take us to spring break, which please send me your opinions on spring break. Some people may want to continue to have regular meetings, especially since I know a lot of people are looking for that connection and to keep up with schoolwork and keep up with the routine. So let us know in the chat or in email what your opinions are for spring break, and then we'll make adjustments accordingly. So navigate out to, and good morning to Gabe and Nadia. Go ahead and navigate out to Google Classroom. This was originally going to be a lab, and we're going to do this in kind of a hybrid way here. I only have about 30 different windows open.
Is assignment 145?
This is assignment number 145. And I totally opened the wrong one. There we go. So we're looking at assignment number 145. There's a couple different parts of this assignment, so I'll walk you through it right now. There are 2 sheets. There's this PDF called Weird Climate Unit 5 Activity 2. This is from a whole curriculum that I put together about climate change. So we're going to kind of do one of these activities, and I'll show you how we're going to do that. And then we're also going to do this sea level rise activity, and this is going to be more of a demonstration, but it is something that you could absolutely do at home in order to prove it to yourself. I attached a bunch of videos here. We're going to be going through 2 of these videos, and the other 2 I highly recommend for you to watch at home. One of them being this Bill Nye video, What If All the Ice Melted on Earth? It's really well done, and it helps drive this point home. And then there's a little bit, good morning, Dade. There's one more that is a little bit more complex that is called Sea Level Rise is So Much More Than Melting Ice. And this video is really fantastic from the perspective of explaining why sea level is different all over the world. It's not as simple as here's the sea level in the ocean and that's it. The ocean actually has topography of its own. It has high points and low points, and it's really fascinating to see how that can be modeled. Now, those are not things that you absolutely need to know, but they help to explain why sea level rise is such a complicated issue. So what we're going to start with today is this idea of the thermal expansion of water. So we're going to start with a demonstration and explanation. I want you to treat this, and we're going to go through the activity first and then the video. I want you to treat this as if it were a lab, just from the perspective of trying to collect data. All right, so as we go through this, you'll be able to collect some data. Good morning, Mizan. So this is the PDF. And there's a lot of information in here. There's a lot of background information. What we're talking about is we're talking about as ocean temperatures rise, sea levels rise. This is actually not too complicated to do a demonstration or experiment at home. The main problem with doing a demonstration or experiment at home is it requires a lot of time. And so because it requires so much time, then that's something that we will, we're gonna just watch the video to see how it works. What requires less time, oh, it's telling me my internet connection is unstable. So if I hop in and out, I apologize. What requires less time is sea level rise. And I'm going to start off with this experiment so that by the end of class, by about 10:25, we will have some data to work with. So I'm gonna show you what my setup is here. I've got this lamp back here that's heating up these 2, oh, you can't see me yet. All right, I've got this lamp back here heating up these 2 containers of water, and these 2 containers of water both contain just some food coloring. The one container, as you can see here, it has like a glass that's upside down. This glass that's upside down is going to be a platform for some ice. And so this is going to model our land ice. So ice that's on the land and that melts on the land and then melts into ocean that surrounds it. All right, I hope that you can see that. There's my glass in the middle here. The other container here is meant to simulate ocean ice. So this is just going to be ocean water, and we're going to drop some ice in. So as we start this, I've got ice. As we start this, what we're going to do is we're going to put 2 ice cubes in the ocean water, and I'm going to mark off with a Sharpie the level of that ocean water. And we're going to track over the course of the next 45 minutes what happens to that level of ocean water. What do you predict is going to happen to the ocean water? You can unmute and participate.
That it's going to overflow to the land.
Okay. Any other predictions?
The ice cube will melt, causing more water to be in the can or tub.
Okay. All right. Those are some predictions. Go ahead. Maybe make note of those predictions on this document that I shared with you on number 145. And then what I'm going to do is I'm going to try to squeeze, if I can, I'm going to squeeze 2 ice cubes on the land here. And so those, whoa, stay on, no! All right. I'm going to try to keep these ice cubes on the land, and I'm going to make a note of where the ocean currently is, the sea level currently is, just like I did with the ocean ice. And what do we predict is going to happen with this one?
Wait, which one is that one?
This is the land ice. So the ice is on a glass that's in the middle, upside down. It is not currently in the water, and I marked the level of the water as it stands currently. So this is meant to simulate like the ice sheet that's on Greenland, the ice sheet that's on Antarctica. I'll let you think about it. In the meantime, let's go ahead and we're going to watch a quick video about what happens with the thermal expansion of water. And what I want you to do while we're watching this video, I'll show you what I want you to do here in just a second. So we are going to do the other experiment first. I'm on the PDF right now. The experiment that we're going to watch is generally this experiment right here, where we're going to put some water in a bottle. The person doing this is putting some water in a bottle, and then they're going to track to see, as it heats up, what the level of that water in the bottle is. So I want you to make some predictions before we watch this, and what I'm going to ask you to do is to answer part 1 and the summary. Don't worry about part 2. We're not going to see anything about part 2, but I'm going to ask you to answer. This is just an activity, not a lab report. I'm going to ask you to answer part 1 and the summary. All right, so you might want to have that up, part 1, while we're watching this video.
Do you mind if we put it on the doc and answer?
Yeah, you can absolutely put it all on the same doc and answer it. That's a great idea.
Things expand when they get warmer. For example, air will expand, like the air in hot air balloons, or even bridges will expand. That's why they have to have those little metal teeth so that the bridges don't crack when they expand. And of course, water expands when it gets warmer. And that's really important because there's a lot of water on the planet Earth. And as the Earth gets warmer, that water is going to expand. And that expansion is going to lead to sea level rise. And that has a lot of big implications. So to experimentally show that water expands when it's heated, we have a 100-watt light bulb, and that's in a reflective casing. And then we have a 750 milliliter clear plastic bottle, and we have some food coloring in there so it's visible. And then we have a straw, and the straw is poked down through the bottle cap, and it's sealed with a little bit of caulk so that no water can leak out. It's also important to note that there's no air in the bottle or in the straw below the water line. And that's important because if we have air, we're not really testing the thermal expansion of water. We're looking at water and air, and we're not going to be able to separate which is which. So we're going to start off at time equals 0, and we're going to look at the level of water in the straw. So at time equals 0, we have 13.5 millimeters of water in the straw. At 15 minutes, it jumps up to 31 millimeters, almost double. At 30 minutes, we go to 43 millimeters, and as that heat continues to make the water warmer, we jump up a half hour to 60 minutes at 71 millimeters, another half hour, we're at 90 minutes, 136 millimeters, and finally we get to the 121-minute mark, that's 2 hours, and the water is almost at the top of the straw. 135 millimeters. So at that point, we have to stop the experiment because the water is going to overflow and we can't continue to measure at that point. If we turn the light off and we wait a while, as the water cools, it'll contract and return to the original position. Now you might wonder, why is all this important? I mean, we've shown that water expands as it's heated, but why does it matter? One reason that it matters is that the average global temperatures are rising, and they're only rising a little bit. But that little bit has big consequences because we have quite a bit of water in the ocean. And even if that water only expands a little bit, there's so much of it that it contributes to sea level rise. In fact, thermal expansion, along with ice melting from the poles, is one of the main things that drives sea level rise. So there you have it. That's the thermal expansion of water and one of the consequences of thermal expansion of water. This is Dr. B, and thanks for watching.
Okay, so we saw here that as water gets warmer, what happens to it?
The levels of the sea rise.
Absolutely, and in the ocean, that's what causes a lot of sea level rise. And that we saw over the course of 2 hours, it rose quite a bit. Is there more water in here after 2 hours?
No.
Nope. Same amount of water. It's just expanding, right? So let's go back here. And I want you to answer part 1. Numbers 1, 2, and 3. And then we'll get back, we're gonna watch another video and we will answer the summary. That'll help. So the second video will help us answer that summary. Go ahead, create a new document or use the sea level rise document, this one right here, to answer the 3 questions on part 1. I'm gonna give you a couple minutes to do that right now.
Will we be going back over it, like discussing each other's answers?
Yes.
Okay.
Make sure you have them answered first, though. Some fresh work music. Put your hand up in the video or let me know in the chat if you need more time.
I've been held up in this city for a while due to the rain. I hope that the rain will never stop.
Oh, I see. So as soon as it stops raining, you'll leave.
All right, go ahead, finish up. If you're not finished yet, that's okay. I want to make sure that we get to everything today and have enough time for discussion. So let's talk about real quick what the relationship is between temperature and water volume. Someone want to chime in?
Water temperatures with increase, like to the wall, they build up and turn to water. The molecules expand.
Excellent. So the temperature increases as the molecules expand. Is that what you said?
Yeah.
All right, go ahead, Ayana.
As the water cools, it will contract, as well as the same happens.
Excellent. So relationship between temperature and water volume, I'm just going to make a quick note here. Now, if you write the same thing I do, I know that these are not your words. As goes temperature, so goes water volume. As temperature increases, water volume increases. As temperature decreases, water volume decreases. In general, all right, there are some exceptions to that, especially as water gets really cold, like below 4 degrees Celsius. But for most of the ocean, this holds true. All right, so generally, as climate change increases, we are going to see rising sea levels. So how does this lab model that sea level rise with warm temperatures? Specifically, how are we able to measure it out of this lab?
I would say probably like
Speak up a little bit. Okay.
I was trying to say something like along. Wait, can you repeat what you said? I'm sorry.
So what in this lab is being measured in order to determine that warming temperatures increase sea level rise?
The volume of the water inside the tub.
The volume of the water inside the bottle, right?
Yeah.
And so it was measured with a straw and a ruler, right?
Right.
Okay. So this is important because this is a model, and we talk about models a lot in environmental, and we know that models are really helpful for visualizing things and for predicting things. However, they lack in complete accuracy because we know the ocean actually behaves a lot differently than water in a bottle. So for number 3, what did you say about how we can change the model to make it a better fit for what we're observing in sea levels?
I said we could use a bigger container for the water and a bigger ice cube to kind of match a proper scale to our planet.
Good. So you're talking about the demo that I have going on back here?
Yeah.
All right. So I agree. Bigger container, more ice cubes. As far as the demonstration that we just watched with the thermal expansion of water, I agree that a bigger container would be super helpful. What else might be more helpful to making the model a better fit?
He didn't use air, right?
Yeah, there was 0 air inside of that container.
So couldn't we like use that, because that's not exactly an accurate like show of what like the water is, because there's air in the air. So
Yeah, there is absolutely air in the ocean air system. And the reason that air wasn't used is because that would affect the ability of the water in order to climb up the column.
But then that could be like one of the different contributing factors that you could add onto the experiment.
Absolutely. So there are other factors that influence, can we say, real world sea level rise?
Yeah.
Good morning. So I think there are quite a few things that you could say for your answer to number 3. So let's watch one more video that helps to explain what's going on the molecule basis and why sea level rise is actually happening due to thermal expansion. And this video is a little corny. It was made a few years ago, not too old, all right? But if you can deal with the corniness, I think the science is really good. It's really well done.
One of the things I couldn't help noticing on my trip to the aquarium was how it sits right on the water. And while I was sketching, I noticed certain unusual features. For instance, this ramp around the aquarium slopes slightly up. So when I got back to my studio, I looked this up online and I found out that this ramp goes up by design to make room for the rising waters that will happen around the globe in the 21st century.
So if you warm up all of the oceans, that water is going to expand and ultimately it's going to rise.
That's Bud Riss, president of the New England Aquarium.
And what that means is over the next several decades, the water is going to be at least 1 to 2 feet higher than it is today.
So why is the water inevitably going to rise?
Well, start by thinking of the ocean as a dance floor. You see, under normal temperatures, the ocean's water molecules move like they're doing a slow dance. Nice and easy. And a lot of them can fit on the dance floor. But pump up the jam, and every one of those molecules starts moving, pop-locking, getting down and taking up a lot more room on the dance floor. That spacing out of faster molecules is exactly what thermal expansion is, and one of the major reasons oceans will rise in the 21st century as they inevitably heat up.
Nice. Got it. But what can we do about this?
Well, if we move from the dancing water molecules to the increase in temperature, to the CO2 increase, to the source of the CO2, we see that we can all make a big difference in this process by changing our habits at home, on the road, and in how we consume.
All right, so what was the point? What are you seeing on a molecular basis when water heats up?
Is it saying that it vibrates or something along those lines?
Absolutely, it vibrates, and when it vibrates, what has to happen with those water molecules?
Don't they heat up and then cause the water to rise and evaporate due to friction and stuff?
Well, it definitely causes rising, but what's happening in the meantime as those molecules are moving faster? Go ahead, Mariana.
They're like gaining energy or something?
They have more energy, and then what happens to the molecules? What happens to, I guess, the distance between those molecules?
They spread more space between them?
100%, yes. There's more distance between those molecules, and as there is more distance between the molecules, that means that the sea level is going to go up, all right? Now, on the other part of this, of what we're doing today, the other part of sea level rise, the experiment that I have going on behind me, that 45 minutes might just be enough time to see some results. We just did number 1 together, but what I want you to do is I want you to write in here, this is on the sea level rise document, I want you to write in what the setup is, and I'm gonna go over it again. I'll stop sharing this and I'll put the video back on so that you can see what I set up. And I want you to make sure that you have your predictions of what's going to happen in each cup. So remember, I have 2 containers here. One container is simulating the ocean. I had put 2 ice cubes in here. Those ice cubes have since melted. And this one simulates ice on land. So I put a glass upside down inside of this container. and then I put 2 ice cubes on top of that glass, and that simulates the ocean surrounding somewhere like Greenland or Antarctica. There's my line, there's my line. So make sure that you have responses to both numbers 1 and 2 here. And I think I definitely have enough results that we can examine those results. Again, this is a really easy experiment to set up at home. So I'll give you a minute to go ahead and write down your answers to 1 and 2. Yes.
What number 1 is a question? Number 1 looks like directions.
Yep. So number 1, I want you to write down what the experimental setup was that I put together.
Oh, okay. Like the procedures, right?
Yep.
Okay.
Let me know if you need more time.
Is this the entire lab report?
So we're not writing a lab report for this. This is just an activity. I'm not actually having us do any more lab reports until we get back into school.
Okay.
All right, take another 30 seconds. All right, so at this point, you should have at least a rough outline of the procedures and predictions about what would happen in each cup. now we're going to do together, we're going to record the observations. So let me turn the video back on. And let's first take a look at the sea ice. So you should be able to see the line, and I'm trying to hold it as level as possible. The line is exactly where it started. Why did the sea level ice not increase the level of sea level at all?
Did it melt?
Well, and that ice, it totally melted, right? There's no more ice in there. When we put the ice in, it displaced an equal amount of water that was contained in the ice. So when the ice melted, it did not change the overall volume of the entire ice-water mixture. All right, this is why if you have ice in your lemonade on a hot summer day and it melts, your lemonade doesn't overflow. It stays the same level. So ice in water, actually, it just stays the same level from beginning to end, no matter how much ice melts. It's a major misconception that people have that when icebergs melt that it raises sea levels. It doesn't. Keeps it exactly the same. So icebergs melting is not our problem.
Wait, isn't that like the whole thing with like water replacement?
How do you mean water replacement?
Like, it's similar to how like crows will like drop stones into a little like water area so that the water raises up to their level so they can like drink it.
So what that's doing is that's displacement, all right? So crows are using displacement, and that is exactly what's happening in this container here. Now, I don't know how well you can see it on the video. I'm gonna bring it really close so you can hopefully see that line. What's happening is that line is just a little bit lower than where the current sea level is, because if you take a look, the ice is probably about half melted at this point. And so the water from that ice has fallen into the ocean and made the sea levels rise. So what we're concerned about is not icebergs melting, but glaciers melting. Glaciers that are on mountains, on land, glaciers that are on the surface of Antarctica and Greenland. Those glaciers melting, that's what's going to cause 2/3 of the sea level rise. All right, 2/3 of the sea level rise is caused by ice melting from land into the ocean, and the other 1/3 of sea level rise is caused by thermal expansion. So it's kind of a double whammy. We know that ice melts because temperatures go up, and we also know that water expands because temperature goes up. So both of those things cause sea level rise. So make a note of your observations from both, this is the land ice container, and also the ocean ice container. Noticing that those levels are lower in the ocean ice container than the land ice container. So you should be answering numbers 4 and 5 right here.
I did get confused on which one you were talking about.
So
yeah, but now I understand now that you explained.
So the sea ice, right? This is the sea ice, the one where there's no land, there's no little glass in the middle, right? I just put the ice directly in. And this one is the land ice, where there's the glass that has the ice on top in the middle, and we saw that the levels of the water actually increased. As the ice melted, that water got added to the total amount of ocean.
So I have a question. When like the when some of the parts of the glacier like break off, does that also have something to do with like the rise of sea level, or is that different?
100%. So whenever glaciers melt, that water that was trapped on the land and was not adding to the whole sea level, was not adding to the volume of water in the ocean. But as soon as it melts and it runs off into the ocean, that makes the sea level rise, that makes ocean levels rise. So I'm making a couple notes here. Sea ice is like icebergs, land ice is like glaciers. So go ahead, finish answering numbers 4 and 5. All right, who needs 30 more seconds? All right, so let's touch base real quick as we're finishing up here. I hope that you were able to record your observations and at least start a conclusion about what happens to sea level with land and sea ice melt. You should be addressing both land ice and sea ice in your answer. The last thing, and this I guess is kind of your homework. I guess I said the dreaded H word. You're at home anyway, so all of it's homework. But why does water volume, so this is from the summary from the Weird Climate Activity. Why does water volume increase with increasing temperatures? Remember, we watched that video, the one where the water molecules are dancing. So that should give you some hints as to how to answer that question. How will the change in ocean volume change coastal areas? use examples in your answer. There are a couple of videos that I posted that will help you answer that in case you don't have an idea about how to answer that question. But yes, Dade.
Wouldn't it flood coastal areas because they're right next to the sea level? For example, Florida.
Right. So there's a difference between being right next to the ocean and being at ocean level. Okay, so be very careful when you answer that, that you are making that distinction, because there are places in Western United States that you can go and you can see the ocean. You can walk right up to a cliff and see the ocean. However, that cliff is 10, 20, 50, 100 feet above sea level. And so there's no chance of that area flooding. Whereas in your answer, in what you just said, Dade, you pointed out that in Florida, it's really low and they are very susceptible to flooding, okay? And then you should be able to give a great answer to, are there other causes of sea level rise? If so, what are they? Describe them and how they're influencing sea level, because we just saw 2 demonstrations today, and you should be able to connect both demonstrations in this one answer. Any other questions? Mr. Tapp, did you have anything? He is shaking his head. Great, it's wonderful.
No, this is good.
Good. It's wonderful to see everyone. We'll talk about question set 7.1 tomorrow. We're going to start, so computer science will start in about a minute. I'll be right back on. Stay safe.
I think everyone froze.
Get some exercise. I don't know if you saw the exercise video that I posted from my niece, but like I'll keep posting anything that she does. It was a quick 3.5-minute workout, and I really enjoyed it. So
yeah, Mr. Dutton, that was amazing.
Okay, good. I'm glad you enjoyed her. Maybe that should be our workout routine. I'll make Kaylin do a video every day.
Yeah.
Definitely.
That'll be fun.
All right. I will tell her that you guys gave her all sorts of praise.
Tell her she has a fan base.
She has totally
Yeah,
has a
she
fan
has a
base.
fan base. We have to make like a nickname for like what we should be called.
All right. Well, and she goes by Kay, so maybe it should be Kay's workout video or something. She has a YouTube channel.
She does.
Absolutely
That's
has a YouTube channel. So I'll make sure that I've got that linked. All right. Stay safe, everyone. See you tomorrow.
Bye.
Bye.